Okay, so today we're moving into trigonometry. So the word trigonometry comes from two Greek terms, trigon meaning triangle, and metron meaning measure. So we can use these. Our trigonometric ratios are simply measures of the lengths of the sides of a right triangle. So we've been working with right triangles all chapter. Today is no different. So when we say the sine of angle A, if angle A is right here, the sine of angle A is the leg opposite of angle A over the hypotenuse. Okay, so what that means is we're going to do the opposite of angle A, which is just A, that small a, and then over the hypotenuse. The hypotenuse is always that longest side, which is C. Our cosine of angle A, or cosine A, is going to be the leg adjacent, we've used the word adjacent before, to angle A, over the hypotenuse. Okay, so our leg adjacent, which is right next to it, is going to be that side B over our hypotenuse, which we've already found is that side C. Our last trigonometric ratio is going to be our tangent of A, which is going to be the leg opposite angle A over the leg adjacent angle A. Okay, so that means that we're going to have the leg opposite, which is our A, over the leg that it's right next to it or adjacent, which is B. Okay, so one way we can remember this is using this saying right here, which is SOHCAHTOA. So when we are looking at sine, we're looking at SH or SOH, which is sine is opposite over hypotenuse. So O over H. Cosine is A over H, which is adjacent over hypotenuse. And TOA, which is that tangent, and tangent is opposite over adjacent. Okay, so we're going to use these constantly. Okay. So we're not going to worry about this right now. So what we're going to do is we're going to talk about the sine, cosine, tangent ratios for angle T. So angle T is this right here. So our sine of T is going to be our opposite. So our side that is opposite of T is 8 over our hypotenuse. Our hypotenuse is always the side that's opposite our right angle. So in this case, it's going to be 17. Okay. Our cosine of T is going to be our adjacent, which is 15, over our hypotenuse, which is 17. And our tangent of T is going to be our opposite, which is 8, over our adjacent, which is 15. So when we're writing our trigonometric ratios, that's all we're writing is that sine, cosine, tangent, and the ratios that come out of it. So for this one, now we're going to look at G. So for our sine of G, we're going to do our opposite of G, which is in this case 15, over our hypotenuse, which is 17. Then we're going to have cosine of G, which is going to be our adjacent. So in this case, it's going to be 8 over our hypotenuse, which is 17. And our tangent of G is going to be our opposite, which is 15, over our adjacent, which is 8. Okay, So writing those ratios should be easy when we're using our SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So last chapter we used similar triangles to measure distances indirectly. We can also use our trigonometry to measure distances. Okay. So in the Leaning Tower of Pisa in 1990, it was closed to public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce the tilt from the vertical. The engineers' efforts were successful, resulting in a 5-degree tilt reduced from that 5.5 degrees. And we want to figure out how far away the base of the tower is when we let an object fall from the top. So what that means is in this picture, we want to know what this distance at the very bottom is. Okay? So if we have our angle is going to be this angle right here, which is going to be 5. And we want to know our opposite, and we have our adjacent side. What we're going to use is we're going to use our tangent. So our tangent of our angle, so our angle in this case is going to be 5, equals our opposite, which is this x, over our adjacent, which is this 150. Okay, so when we're solving for x, what we're going to do is we're going to multiply both sides by this 150, which leaves us with x equals 150 tangent of 5. So when we put that into our calculator, your sine, cosine, and tangent buttons are above your comma and parentheses buttons on your calculator. So if you type into your calculator 150 times tan, it's going to open a parentheses, you're going to type 5 and then close that parentheses. When you do that, that gives you about 13.1. In this case, we are going to round it to the nearest foot. So we're going to say that the object will land about 13 feet away from the base. Okay, so if we drop an object from the top of the tower, it's going to land about 13 feet away from the bottom of the tower. Okay, for these next two, what you're always looking at is what angle you have. So right now we have an angle of 54, and we know our opposite, and we know our hypotenuse. So using our SOHCAHTOA, we're going to have our sine of this 54 equals our opposite, which is W, over our hypotenuse, which is 17. So to solve for it, we're going to multiply both sides by 17, which leaves us with W equals 17 sine of 54. When we put that into our calculator, that gives us 13.8. Okay, and our next one, we have this angle right here is 28, and we have our opposite and we have our adjacent. So if we use our SOHCAHTOA, that means we're going to use our tangent of that 28 equals 1 over W. So to solve for W here, we are going to multiply both sides by W. Which leaves us with W tangent of 28 equals 1. And we have to get this tangent away from W, so we are going to divide both sides by that tangent of 28. Which leaves us with W equals 1 over tangent of 28 And when we do that in our calculator, that should give us 1.9 when we round it to the nearest tenth. Okay. And our last one here, this is the angle we've got. We have our adjacent side and our hypotenuse. So we're going to use cosine. So we've got cosine of 33 equals our adjacent, which is W, over our hypotenuse, which is 4.5. So if we multiply both sides by 4.5, that leaves us with W equals 4.5 cosine of 33, which means that W equals about 3.8. Okay. This last one, it says a section of Filbert Street in San Francisco rises at an angle about 17 degrees. So we've got the 17-degree angle. And if we walk 150 feet up this section, we want to know what the vertical rise is. So right now we have this angle right here. We have our opposite and we have our hypotenuse. So we're going to use sine. We're going to do sine of 17 equals x over 150. So to solve for that, we're going to multiply both sides by 150. That gives us x equals 150 sine of 17, which leaves us with x equals 43.9, and it tells us to round to the nearest foot. So our vertical rise is about 44 feet. Okay. So if you know the sine, cosine, or tangent ratio for an angle, you can use the inverse function. So the opposite of sine, the inverse of sine, the inverse of cosine, and the inverse of tangent to find the measure of any angle. Okay, so what that means is down here, it wants us to find x. So right now, we have our opposite and we have our hypotenuse. So when we do that, if we have our opposite and a hypotenuse, that means that we're using our sine function. So if we have the sine of x equals that 6 over 10, when we put it into our calculator, we are going to take x equals the sine inverse of 6 over 10. So to do your sine inverse in your calculator, you're just going to hit the second button and then your sine button. It'll open that parentheses. You're going to put 6 divided by 10, close the parentheses. That leaves us with x equals 36.9 to the nearest degree. That gives us 37 degrees. Okay. And our next one, it still wants us to find x. So we have our adjacent and we have our hypotenuse. So we're going to use cosine. So the cosine of x equals 15 over 20, which gives us that x equals the inverse of cosine of 15 over 20. So x equals 41.4, which rounds down to just 41 degrees. Okay, so our got it problems, you don't have a figure at the right, but we're going to draw it. We've got P, T, and Y. We've got 141. And we're looking for Y. So we're going to have tangent of Y equals 100 over 41. So Y equals the inverse of tangent of 100 over 41. So y equals 67.7, or just 68 degrees. And this last one, if we have the lengths of all three sides of the triangle, does it matter which trigonometric function we use? It does not. Does not matter.